This is Earth, with a diameter of 12,756 kilometers. And this is our Milky Way galaxy, with a diameter of around 100,000 light-years, or we can say these many kilometers. But on the grand scale of the universe, our galaxy is just like a particle of dust out of many. Regardless of their size, they all have one thing in common. That is, they are all made of atoms. Atoms are considered as the basic building blocks of the universe. They consist of protons, which are positively charged particles, neutrons, which are some neutral particles, and electrons, which are negatively charged particles. All the stuff we can see, touch, and interact with is called normal matter, also known as baryonic matter. As an obedient student, this matter follows the laws of physics, like electromagnetism, the strong and weak nuclear forces, and gravity. According to current scientific understanding, only about 5% of the universe is made up of this baryonic matter that we can see, including me, you, Earth, planets, stars, and galaxies. So if everything that we can see and touch makes up only 5%, then what is the other 95% of the universe made of? The universe is more beneath than it's seen. According to studies, another 27% of the universe comprises of dark matter. Dark matter is one of the most significant mysteries in modern physics. To understand dark matter, we have to go back to 1933. In 1933, a Swiss-American astronomer named Fritz Zwicky noticed something strange about a big group of galaxies called the Coma Cluster. He figured out that all the stars he could see in the cluster simply didn't have enough mass to create the gravity needed to hold the cluster together. The galaxies should have been flying apart. Zwicky realized there had to be something else there, something unseen providing the extra gravity. He called it dark matter. For many years, this idea of missing mass was debated. Until the 1970s, two American astronomers, Vera Rubin and W. Kent Ford, provided strong evidence confirming Zwicky's hunch. They looked at how stars move within individual galaxies and found the same problem on a smaller scale. The stars in a galaxy were orbiting the center much too fast. The visible stars only accounted for about 10% of the mass, which was needed to keep them from being thrown out into space. Rubin and Ford discovered that the speed of stars orbiting a galaxy's center didn't decrease as you moved farther from the center, as you'd expect if all the mass was concentrated in the middle. Instead, the stars maintained their speed or even sped up a little. This meant that the mass within the star's orbits had to increase steadily as you went outward. It was like the galaxies had a hidden, extended mass distribution surrounding them. But here's the crucial part. We don't see any light coming from this extra mass. It's completely dark. That's why it's called dark matter. It's a matter that we can't see, but we know it's there because of its gravitational pull. It's the invisible glue holding galaxies together. Normal matter and dark matter comprise around 32% of the universe. The remaining 68% of the universe is made of dark energy. Dark energy is a mysterious force that is thought to be responsible for the accelerating expansion of the universe. It is a hypothetical form of energy that is estimated to account for around 68% to 72% of the universe's total energy and matter. Scientists first began to suspect the existence of dark energy in the 1990s, when they'd observed that distant supernovae were dimmer than they should have been. This observation suggested that the universe was expanding at an accelerating rate, which could not be explained by the known forces of gravity and matter. Since then, a number of other observations have provided further evidence for the existence of dark energy. For example, measurements of the cosmic microwave background radiation, the afterglow of the Big Bang, have shown that the universe is more uniform than it would be if it were only filled with matter. This uniformity suggests that there must be some form of energy that is pushing the universe apart. Despite its importance, scientists still do not know what dark energy is. There are a number of competing theories, but none has yet been proven. Some scientists believe that dark energy is a new type of fundamental force, while others believe that it is a manifestation of a more exotic phenomenon, such as the quantum vacuum. Dark energy is thought to be responsible for the accelerating expansion of the universe. This expansion is causing the distance between galaxies to increase over time. As the universe expands, the density of matter decreases. This means that the gravitational attraction between galaxies is becoming weaker. Dark energy is also thought to be responsible for the observed flatness of the universe. The universe is said to be flat, if it has the same geometry in all directions. If the universe were curved, the distance between 2 points would change depending on the direction in which it traveled. Scientists can measure the effects of dark energy by observing how galaxies and other objects are moving. For example, they can measure the redshift of light from distant galaxies. Redshift is the phenomenon in which the wavelength of light is stretched as it travels through space. The amount of redshift of light from a galaxy can be used to determine its distance from Earth. Scientists are continuing to study dark energy in order to better understand its nature and its effects on the universe. They are also exploring ways to harness dark energy for practical purposes. For example, some scientists believe that dark energy could be used to power spacecraft. The study of dark energy is still in its infancy. However, it is one of the most exciting areas of research in astrophysics today. As scientists learn more about dark energy, they will better understand the universe and its ultimate fate. Thanks for watching this video.